we will solve a problems on effort and power of Porter Governor and Hartnell Governor. So basically, till now, whatever was the procedure to solve the problems on the power and the effort, to solve the problems on the Porter Governor and the Hartnell Governor, that procedure, or you can say that diagram will not change. Okay, nothing will be changed. Everything is same. Only at the end, you have to calculate this extra. That is what you have to calculate. You have to calculate this effort and power of a Porter governor and a Hartnell governor, right? So this is nothing but extra part, and for that we have already done the derivation and found out the equation for the P. What is P? That is a effort of a Porter governor, and similarly we have seen the formula for the power of the governor. So we'll use that and we'll solve the problem. Okay, and from tomorrow's lecture, we'll start with the next point, that is a gyroscope. Okay, so if you have any doubt in this particular model of a governor, you can contact me by any mode. Okay. So let us see what is the problem. A Porter governor has equal arms, each 250 mm long and pivoted on the axis. See, the problem definition is same as we have solved. Okay, December 2014, Theory of Machines, question paper code 14809. Each ball has a mass of 5 kg and the mass of central load of the sleeve is 25 kg. The radius of rotation of ball is 150 mm and the governor begins to lift, and 200 mm when the governor is at maximum speed, right? So find the range of the speed. So you can see that find the range of the speed. So what you have to find, n2 minus n1 is equal to something. So till now, whatever procedure you have followed to solve the problem on the Porter governor, you have to follow the same procedure, and then only further for additional calculations are nothing but a sleeve lift, governor effort, and power of the governor. So you can see these 3 points are nothing but additional, as we have seen. Okay, and now in this case, you have to solve for the two cases. One, the friction at the sleeve is neglected, and the friction is equivalent to 20 Newton. Okay, so basically now till now you all know that when the friction is neglected, what is the formula? L square is equal to small m plus capital M divided by m, okay, into 895 upon h. Okay, if q is equal to 1. Okay, so if q is not equal to 1, this formula changes. How this formula changes? N square is equal to m plus capital M 1 plus q divided by 2 divided by small m multiplied by 895 by h. Okay, so this formula is nothing but when the friction is at the sleeve is neglected, right? So this is what you have to remember, right? And I think they are not so difficult. And when the friction at the sleeve is equivalent to 10 Newton, so if they are saying that F is equal to 10 Newton, so we have to find out plus minus F. Now you know that when the frictional force is upward, okay, take it minus. When the frictional force is downward, take it plus. When the frictional force is upward and the sleeve movement is downward. When the frictional force is downward, then the sleeve movement is upward, right? So this all you know, and you have to just change the formula, right? So we'll start. So they have said that a Porter governor has equal arms, each 250 mm long, and pivoted on the axis of rotation. Now basically from this what you can understand? That, okay, you can understand that the diagram will be like this. So let us call this as a P point. Let us call this as a D point. Okay. So the point P and D, that is both the points will be on the axis of rotation. That is a spindle axis, or you can call it as a governor axis or axis of rotation. Spindle axis, governor axis, axis of rotation, whatever you can call. Okay. And then we'll draw like this. Then we'll draw like this. And this is R, this is L1, and this is L2. Right? Is it clear? So they are saying that this L1 is equal to 250, this L2 is equal to 250. Okay. So in this case, so this will be alpha, this will be beta. So Q is equal to 1 because alpha is equal to beta, right? So this is your case number 1, what they have given, right? So next. So M is equal to 5 kg, capital M. What is capital M? They are saying that each ball has a mass of 5 kg and mass of the central load. M is capital M is for Porter governor. Capital M is nothing but the mass of the central load, right? So capital M is equal to 25 kg. Then they are saying the radius of rotation of ball is 150 mm when the governor begins to lift. Means what? The governor is at a minimum speed, that is at N1. So at N1, what is R? R1, 150 mm. Take it in meters, 0.15 meter. Similarly, they have given when the governor is at a maximum speed, R is equal to 200 mm, 0.2 meter. Find the range of the speed. Okay, and then they have given that when the friction at the sleeve is neglected, case number 1, and the friction at the sleeve is equivalent to F is equal to 10 Newton. Now tell me, have you understand this problem definition? Okay, so what you have to find out? So you have to find out the N2, N1, X, P and power. P means what? Mean effort. Now I have given a complete 1 hour lecture on what is mean effort and all what is power. Okay, so now we are just focusing on the problem. So tell me, is there any doubt? Message me okay if you have understand the problem definition. So today we are finishing governor module. Okay, so today is our 8th lecture. Okay, chalo. So next, now as L1 is equal to L2, now this I have already explained. The pivots are on the axis, that is alpha is equal to beta, Q is equal to 1. L1 is equal to L2 given, na? So I will draw a diagram. So let us say this is a minimum position diagram and this is a maximum position diagram. So you can see that L1, now L1 is equal to L2, they have mentioned that is this 250 mm and 250 mm. So points P and point D are on the governor axis. This is nothing but a governor axis. Okay. So at minimum position, now what you have to understand, at minimum position, what is R? R1 is equal to 150. So I have mentioned here R1. At maximum position, what is R? 200 mm. You know that as the speed increases, the radius of rotation of the ball will increase. Okay. And then let us say H1 is the height and H2 is the C. The first problem which I have solved on the basis of based on the Porter governor, same. This problem is same. Only here you have to calculate the effort and the power of the governor. Nothing so much difficult here. Okay. So have you understand? So this is for N1 and this is for N2. So I hope it is clear for you. Now tell me how will you solve next? Okay. So we will solve first for minimum position. We will take case number 1. We will take case number 1 first of all. That is the friction at the sleeve is neglected. So what is the formula when the friction at the sleeve is neglected? N1 square is equal to small n plus m. Basically this formula is like this, na? N1 square is equal to small n plus capital M divided by 2, 1 plus q divided by small n and into 895 upon h1. But we know that q is equal to 1 because point P and point D are lying on the same axis. So beta and alpha is equal to beta. So that is why this q is equal to 1. So 1 plus 2 2 get cancelled. I am getting this simple formula. Okay. So then do calculations. Now tell me H1. How will you find out H1? First of all, how will you find out H1? So you know that H1 is by using this is a right angle triangle, no? By using a Pythagoras theorem, L1 square minus R1 square. What is L1? This is L1 and this is R1. Right? Is it okay? And this is L2. Clear? So find out. So you are getting 0.2 meters. Okay? And then from this you will get N1. So small m is 5, capital M is 25, 895.0.2. See, you have to take it into the meters. Okay? So finally you are getting N1. So tell me, have you understand how I find out N1? Okay? Message me okay. Have you understand this? Okay, so this is very very simple, not so difficult here. Okay, next. Now friction at now case number 2, maximum position. For maximum position, first of all, what you have to find out? Find out H1, H2. What is H2? L1 square minus R2 square. What is L1? Now here this is again L1, na? And this is R2, right? And this is L2. So L1 minus R2 bracket square. So 0.25 minus 0.2. This I have considered in meters, right? So you will getting some answer 0.15 meter. Okay. This is L1 and this is R2. So 0.15 meter. So basically I find out H2. Going to find out H2. Then next formula is what? N2. N2 square is equal to, now you know that for formula N2 square I will get small m plus capital M divided by m into what is the change? 895 upon H2. And what is H2? 0.15 meter. So you are getting N2 is equal to 189.20 rpm. So you are getting N2 is equal to 189.21 rpm. Okay. So considering the case number 1, the first part is over. And then what is range of the speed? What is range of the speed? N2 minus N1, 189.21 minus 25.13 rpm. So till here the problem was same what we solved earlier. Now let's move on to the right. Now sleeve lift. Okay. Now they are saying you have to find out a sleeve lift for a Portal governor. What is the formula for the sleeve lift? You have to remember this formula. Yesterday in the last lecture, I have not gone for the derivation. I am repeating again. I have given you the notes. You go through the derivations because the derivations are lengthy and not necessary to cover in the your examination point of view because we only have a limited lectures. So from the derivation we got slew lift formula. So you have to remember this formula for a Porter governor. Slew lift x is equal to twice into h1 minus h2. Okay. So remember this formula directly. What is the formula for slew lift? X is equal to twice into h1 minus h2. So you are getting a slew lift. Okay. So this is after derivation I have got. Okay. So we have got a slew lift. 0. What is the slew lift total? 0.1 meter. Now governor effort. What is the governor effort? This also. Now this derivation I have already done. Okay. आपण याचं derivation केलंय. काय derivation? P is equal to C into small n plus capital M divided by G. What is C? C is nothing but the increased speed. What is P? Effort of the governor. Small n plus capital M into G. Okay. Now first of all, C is equal to percentage increase in the speed. Now how will you find out the percentage increase in the speed? So in the derivation, I have given you this formula. What is this formula? C into N1 is equal to N2. Basically it is like this. C is equal to N2 minus N1 divided by N1. So from this formula, you can calculate the percentage increase in the speed, right? So in the derivation, we have seen this that Cn1 is equal to N2 minus N1. That is C is equal to N2 minus N1 upon N. So from this ratio, what you will get the percentage increase in the speed, right? So C you are getting 0.115, okay, and then calculate P. Now you know M you know, capital M, small m, G you all know, okay. So what you are getting governor effort 45.53 Newton. So it is in Newton. See, N2 minus N1 upon N should be in RPM. So you are getting this 0.115 constant value, 5 kg, 25 kg, and 9.81. P you are getting in Newton. Okay, and what is the last? Governor effort, governor power. What is power? The formula for power is very simple. Formula for power is P into X, that is effort multiplied by slew lift. Okay, so 45.53 multiplied by 1, that is power is nothing but the 4.553 Newton meter. Okay, so I think if this problem arrives in your paper, normally the problem on the Porter or the Hartnell Governor will obviously come in the paper. So it is very easy. Now tell me, have you understand? So what is the change? This is the change 1, 2, and 3. So this actually we have gone through a very long derivation. आपण खूप मोठं derivation बघितलं P calculate करताना. But to solve the problem, it is very easy. Now message me yes, no, something. Okay. Have you understand this case number 1? Okay. See, in your unit test 1 also, you will have to solve the problems on the Porter or the Hartnell Governor. Okay, great. Now, what is the next step? Can anybody tell me how will you do the case number 2? What is the case number 2? When the friction at the sleeve is equivalent to 10 Newton. Now, can anybody tell me what formula you will use? What formula you will use? Can anybody tell me, please? Yeah. Now, when the friction of the sleeve is equal, now case number 2, now this for Porter Governor, again Q is equal to 1. Q is equal to 1. Now we know that Q is equal to 1 since alpha is equal to beta. So what formula will use? Can anybody tell me? N square is equal to small m plus capital M divided by 2, 1 plus Q divided by small m and into 895 upon h. Right? This is a basic formula. Right? This is a basic formula, but Q is equal to 1. So this formula will reduce like this. N square is equal to, what will the formula may become? Small m into G plus capital M into G plus minus m. This formula changes like this upon m into 895 upon h. Right? So now, since I have to consider the friction, I have to use this formula. Now just tell me when you will use plus h and when you will use minus h. So for N1, what you will use, and for N2, what you will use. Hello. Now this I have shown. Now tell me for N1 what you will use, plus F or minus F. If I have to write here
minus F.
Minus F. Very nice. And for N2 you will use plus F.
Plus
Now,
F.
yeah. Now those who have still not understand this, remember this. For minimum speed, slew movement is downward. So frictional force will be acting upward. Mg is acting downward, so that is why it becomes minus. Okay, and for maximum speed, slew movement is upward. So frictional force is downward, mg is also downward. So you are using a plus. So these are the basic things what you have to understand. Okay. So now directly I will use the formula. N1 square is equal to mg minus f h1. So everything we know here, you have to just put. Now we know that f is in Newton. F is equal to Newton. That is why instead of writing only m, I am writing mg and capital Mg. See, I am multiplying it with capital small g. The reason is that. Okay. So you are getting N1. Similarly, what is the formula for N2? Your N2 is nothing but a small ng plus. See, there is not much change. You have to just add plus f minus. You are getting N1 161, N2 191, and range. Now, considering the frictional force, you know what is the frictional force? Basically, the force which acts between the spindle and the sleeve. Sleeve and the spindle are in contact with each other. They have a relative motion with respect to each other. So there is a frictional force also, which we have to consider if given. So 31.35 rpm. Okay. So range is modified. The range is modified. Initially, without friction, the range was something 25 rpm. Now it is 35.35 rpm. Okay. So slightly it is modified. Okay. Now you will say how to calculate the governor effort. Now sleeve lift will remain same. Now this point is very important. आता हा point लक्षात घ्या. So when the frictional force is considered, the sleeve lift will remain same. X is equal to twice h1 minus h2. Okay. Speed. Percentage increase in the speed. Now percentage increase in the speed will change, right? Why? Because N1, N2 and N1 that has been changed. So what is C? Again, C is equal to N2 minus N1 upon N1. Okay. So this is nothing but a percentage increase in the speed, right? So percentage increase in the speed has changed. So I am getting this constant C is equal to 0.195. Okay. Now governor effort. Now can anybody tell me what will be the governor effort? The governor effort will be P is equal to C mg plus F. Okay. Now this is very important. See what is the original formula? What is the original formula? P is equal to C into small m plus capital M, right, into G. Okay. This is the original formula what we have derived. Okay. Now when you are considering the frictional force, this formula you have to modify just. So what is that formula? So the formula is that P is equal to C into M plus M into G plus capital M into G plus F. Okay. So basically that formula is plus minus F. Okay. But we want to calculate a maximum effort. So I will consider only a plus. I will not consider minus. Okay. So because if you are minusing it, your P will obviously reduce, and we want a maximum effort. Because maximum effort किती आहे तुमच्या स्लीव वरती तो मला कॅल्क्युलेट करायचा आहे. So I'll be considering a plus. Okay. So basic formula is plus minus, but I will be considering a plus because I want is P max. That is a maximum effort. Message me okay if you have understand this. Okay. And if you have understand this, do the calculations and you are getting maximum effort. Yeah. See, if you take a minus F, if you ask me, sir, I am taking a minus F. Okay. That is correct. That is not wrong. But you will not get a maximum effort because we are interested in what is the maximum effort the sleeve is imparting. What is the maximum effort imparted on the sleeve that we have to calculate. So 59.34. Okay. And finally, power of the governor. What is power of the governor? P into X, that is equal to 5.93. Okay. Now tell me, now we have solved a problem on Q is equal to 1 and alpha is equal to beta. Now we will solve one problem where Q is not equal to 1 and alpha is not equal to beta. So so the formula will remain same for the governor effort and the power, only slightly there is small change. That small change we will understand. Okay. Now tell me, have you understand this problem? Have you understand this problem or not? Okay. So we will move on to the next problem. Okay. So we will move on to the next problem. Again, this problem is very same, not so different. Okay. So, but we will solve this one more problem and then we will solve a problem on the Hartnell Governor and then we will stop. Okay. And then from tomorrow we will start with. So this Sunday I will be conducting extra lectures. I think 10:30 or 10 o'clock we will start because I have to conduct extra lectures for a gyroscope because there are total 9 to 10 lectures available for the module number 1. but we have finished only half part, and we have already conducted 8 lectures. Okay. Chalo. So let's start with, so what is given? A Porter governor has a rotating mass of 5 kg each and mass of the sleeve is 30 kg. Upper links are 25 centimeters long and lower links are 35 centimeters long. Now you can see that from this. Okay. Upper links and lower links, that is L1 is not equal to L2. So alpha is not equal to beta. So Q is not equal to 1. First of all, you have to understand this. Okay. So the upper ends of the upper links and the lower ends of the link are hinged at a 4 centimeter from the shaft axis. Hinge at a 4 centimeter from the shaft axis means what? They are at an eccentric distance of 4 centimeter from the governor axis. Okay. Find the equilibrium speed of the governor in RPM when the governor weight rotates at 130 mm radius. Also find the governor effort and governor power if there is a sudden change of 1% in the speed of the governor. So they have given you the change is equal to C is equal to 1%. Okay. So again slightly different problem. See, there are a number of problems. I will be giving you this PPT. I have given you notes. You go through all the problems in the, see, the problems in the notes are different, or maybe some problems may be same. The problems here are solved from the question papers. Okay. And then I have also given you at the end of this PPT problems for the practice. So it is your duty. You go through all the, at least you read the problems. I have given you the complete solution. Okay. Chalo. So given capital M, small n. Now L1 is given 25 centimeter, L2 is given 35 centimeter. Okay. Now I have drawn this diagram. Now you can see that this is the point P. Okay. This is the point P and this is the point P and this is the governor axis. Now as said in the problem, the point P and point D are not lying on the point P and point B are not lying on this governor axis, right? This is the governor axis. Now they are not lying on the governor axis, but they are lying at a distance of 0.04 meter. Okay. See, in the notes, I have solved the same problem, but in that problem, the problem is like this. The point P is lying on the governor axis and point D is lying at a distance of 4 centimeters. So this is the case number 3. So as I earlier said that case number 1 is both the points, point P and point D, right? So the problem can be of 3 cases, point P and point D. This is point D and point P lying on the governor axis, or both are not lying on the governor axis as this is problem, point P and point D, or maybe one is lying on the, maybe point P is lying on the governor axis and point D there. So case number 1, 2 and 3. So there are 3 types of problems already we have solved. Okay. So I think no need to. So then they have given R is equal to 130. Yes, they find equilibrium speed of the governor when the governor weight rotates at 130 mm. So they have given R. So R is nothing but the 130 mm, 0.13 mm. Okay. So let's start. So which formula you will use? आता मला वाटतं तुम्हाला सांगायची गरज नाही की now you can't say that Q is equal to 1 because you cannot say that alpha is equal to beta in this case. Okay. We have to first of all calculate. We have to first of all calculate what is alpha, what is beta, and then we have to calculate the Q. Okay. So Q is not equal to 1 in this case. So I am getting this formula n square is equal to small m plus capital M by 2 1 plus Q. Right? Is it clear? Okay. Now they are saying that find the equilibrium speed of the governor in RPM when governor weight rotates at 130 RPM. Also find the governor effort and governor power if there is a sudden change in the 1%. Now they haven't given here some like minimum speed or maximum speed. Okay. So they are just talking about the mean equilibrium speed. They are just talking, they just want to calculate N, capital N. So that is why they have given you the R and you have to just calculate the N. There is no need to calculate N1 and N2 in this case. Okay. Only after the 1% change in the speed, you have to calculate the governor effort. So I am directly taking this formula n square is equal to this. Okay. You can see here they are told to find out the equilibrium speed of governor in the RPM. They haven't given you the minimum and maximum condition. Okay. Is it okay or not? Have you understand or not? Okay. So first of all, let us find, this is a diagram. Let us find V. So basically, I hope you have understand this. You can write a statement like this: let n is equal to equilibrium speed. Let n is equal to equilibrium speed, and so you have to find out the n. I think that is your aim. Okay. So first of all, let us find. Now we know that sine alpha. Okay. You can find from this sine alpha. What is sine alpha? Sine alpha is nothing but the, you know na, what is sine? What is sine theta? Opposite upon hypotenuse. Now in this case, sin alpha means what? See, I will draw a figure over here. Okay, this is like this, na? So this is L1, this is alpha, and basically this total distance is r. This total distance is r, and this distance is what? What is given here? This distance is what? 0.04 meter. And if I want this y, so what is y? Y is equal to r minus 0.04 meter. So this is trigonometry, what you have studied from the school days. Is it clear? So that is why sin alpha is equal to r minus 0.04 L1. Is it clear or not in this case? Is it clear? Hello? Have you understand? See, if you want, you can find. Yeah, if you want, you can find like this also. Huh? तुम्हाला जर वेगळी पाहिजे, you can also find tan alpha. Tell me what is tan alpha? Tan alpha is nothing but opposite side. Okay, opposite side upon what? What is tan alpha? BG. What is BG here? Yeah, opposite side upon happen. So same. So you can take this distance. Okay. So same. So opposite side upon adjacent side. Okay. So you can either use tan alpha, you can either use sin alpha. So whatever you want, you can use and you can calculate. It's in your hand. So I have calculated for a sin alpha. So I'm getting alpha. So I'm getting alpha 21.1 degrees. Okay. I'm getting alpha is equal to 21.1 degrees. Okay. Next, sin beta. So what is sin beta? Again same. Opposite side upon adjacent side. So r minus 0.04 upon L2. Only in this case, there is a L2 and opposite side is this. Right? Is it okay? Guys, message me. Are you understanding how to calculate the sin alpha, sin beta? तुम्हाला हे समजतंय ना? Okay. Yes. Okay. So beta मिळाला मला. Yes. No. Beta is 14.9. So now see that alpha is not equal to beta. Alpha is not equal to beta. So Q is equal to. Now tell me how will you find out Q? So first of all find Q. So tan alpha is equal to r upon h. Tan alpha is equal to r upon h, right? So h is equal to 0.13 upon 21.1. Okay, h. And then from this, what I am finding, what I am getting, value of h. So value of h. Have you understand how I find the value of h? Tan alpha is equal to r upon h. Okay. Basically, I have considered this diagram. See, this is a diagram. I will draw a diagram here. So let us say this is a point P. Okay, this is some point. This is some point. I am taking this alpha. This total distance is h, and this total distance is r. Okay, so r opposite side upon adjacent side. So I am getting tan alpha is equal to r upon h. Okay, have you understand this? Why I have done this to calculate the h? Now from this I am getting h is equal to r upon tan alpha, right? So what is r? 0.13, and what is alpha? 21.1 degree. So I am getting h. So guys, this is one more new method where you can understand that you can calculate h from the trigonometry, because till now you have calculated h from the formula. For that you should know either n or you should know either h. Okay. Now here I have calculated h in this manner. Okay. Now tell me, have you understand how you find out h? Okay. And now what is q? Q is equal to tan alpha upon tan beta. So I'm getting q is equal to 0.69. Now in this manner I have found out all the terms. Now message me, have you understand how I found out alpha, beta, h and q? Have you understand this? I am just using a trigonometry, not so big something like, okay, not so rocket science. Is it clear? Shall I move forward? Okay, chalo fast. Next. Now use the formula L square is equal to small m plus capital M by 2 1 plus q. Okay, put everything. Okay, very important. If you are not understanding this, m should be in kg. This capital M is in the kg. 1 plus this is dimensionless quantity 825, and this should be in meter h. Okay, so kg meter, you will get answer in there. So n is equal to 126.97 rpm. Okay, is it clear? Okay, now next, governor effort. Now they have said that governor effort. Now governor effort you can find out from this, for a governor effort you can find out from this new formula. You can write this for governor effort. The formula can be like this: P is equal to C. What is the basic formula? C is equal to M plus capital M into G, right? This is a formula. But this formula is for what? This formula is, I have derived this formula for q is equal to alpha is equal to 1. That is alpha is equal to beta and q is equal to 1. Okay. Now further, if you do the derivation, I know I haven't gone for the derivation because there is a very tedious derivation, and I hope you can go through the notes and you will get a derivation. But after deriving the same, when q is not equal to 1, this gets modified. This governor effort formula gets modified, and it gets modified into like this: P is equal to 2m divided by 1 plus q c bracket plus m into g. Okay, so this formula becomes modified in a simple way. So what has increased? What has increased in your the term 2 upon 1 plus q? This is nothing but an additional term which has increased, right? I hope it is clear to you now. Okay, so directly apply this formula. I will suggest you that you directly remember this formula. Okay, hello. Then do the calculations. You are getting governor effort and then governor power. Now, what is governor power in this case? Now the formula for the governor power after derivation. Again, I have to go for a derivation. Now you know that governor power is equal to P into X. Okay, but in this case, X is equal to 2 into H1 minus H2. But in this problem, you don't know X. The X is unknown. The X is unknown because H1 and H2 you don't know. We just know H. Right? Is it okay? So that is why you cannot use this formula. So after derivation, I am getting one more formula which is nothing but governor power is equal to 4c square plus 1 2c upon small m plus capital M by 2 1 plus q into g into h. Okay, this formula is also mentioned in my notes after doing a long derivation. You can go through it and you will get this formula, but you have to remember this formula. So is it okay? Is it okay? Have you understand this? So remember, you have to remember this formula. So there are some 2 to 3 formulas which you have to remember to calculate the governor effort and the power. So put everything. Now what is C? Now we know that C is nothing but 1%, that is equal to 0.01, right? So you have to take C is equal to 1%, that is 0.01, and the rest is known. Okay. So put everything. Now we know that C, we know small m, capital M, Q is, we know Q, we know G, and we know H. Okay. So you are getting a governor effort is equal to 0.0394. Okay. So now tell me, have you understand this problem or not? Okay. So how many formulas you have to remember? This governor power, this formula you have to remember when Q is not equal to 1, right? When you have to get the Q. Okay. When you have to get the Q. Is it okay? Now message me, have you understand this or not? Guys, have you understand this? Is it clear? Okay, chalo. Thank you so much. So basically you have to just understand. So I have taken all the types of problems, no issues. If you go through all the types of problems, you will get to know what are the modifications. Okay. So you can calculate the governor power in this way for this problem. In last case, I calculated governor power P is equal to P into X. Okay, because I was knowing slowly. Yes. Basically, I have already shared the notes, and in the notes there are also many solved problems. But this PPT will be also shared by me on the Google Classroom. No issue. Also, I will be sharing my recorded lectures. Okay, I will soon because I have to work on it, and then I will share my recorded lectures. So if you have missed something, you can go through it. Okay, so next. Now problems on effort and power of a Hartnell governor. Now we'll solve a problem on the Hartnell governor. Now we have a limited time. We will solve only one problem. So basically, again there are some modifications. There are modifications here in the problem. You have to do again I haven't gone through the derivations because again it will take a more time. So I will directly show you the modifications in formulas. There are some modifications in formulas you have to do for the Hartnell governor. Okay. So this problem will not go. So this problem I will give for the homework. I will go for the next problem. Okay. This problem will go for. Yes. Okay. So see, we have this problem on the Hartnell governor. Okay. Now I think for a problem on a Hartnell governor, I think everybody knows how to draw the minimum. Just message me yes or no. Everybody knows how to draw a minimum and maximum position diagram for the governor and how to take a movements. Everybody knows? Yes? Message me? Yeah, okay. It is very, very important because if you are not able to draw the diagram, you are not able to take a movement because it is very difficult to remember the formula for the movements. Sorry, for the Hartnell Governor. For Porter Governor, okay, the formulas we are able to remember. Okay, so chalo. In the Hartnell Governor, the radius of rotation of the ball is 60 mm. Okay, so R1 is given at minimum speed. They have said at minimum speed N1 is equal to 240 rpm, right? The length of the ball arm is 30 mm. Now tell me length of the ball arm is what? X or Y? Anybody? Length of the ball arm X or Y? And of the sleeve arm
X.
X. Okay, chalo, great. So here X is equal to 130 mm. See here I have found out omega 1 also. Now I think this is needless to explain that omega is equal to 2 pi n by 60. So if you know n1 you will get omega 1. If you know omega 1 you will get n1. Fast. Okay, so X. What is Y? Length of the sleeve arm. Okay. What is the ball arm called as? Ball arm is also called as a vertical arm. Sleeve arm is called as a horizontal arm, or it is also called as a roller arm because the sleeve arm is connected to the roller at the end. I hope you have understood the construction. It is very, very important. See, okay. So M, the mass of the each ball is 3 kg and that of the sleeve. Now see, up till now, whatever problem we have solved, I hope you have seen that I have taken M is equal to 0, mass of the sleeve which was unknown or which was not given, but here they have given you, fortunately they have given you M is equal to 4 kg. Now guys, very, very important. You cannot take M is equal to 0. This is very, very important. Is it okay? Clear? Okay, so stiffness of the spring is 20. Okay, great. They have given you S. S means what? They have given you K. Okay, I've basically in the last year when I used to teach this subject, I used to take notation S for a K, but it becomes a confusing. So this time I'm taking it as a K. Okay, so remember this is because we are taking S for a spring force, no? So that is why you remember this, and this K notation is okay for stiffness. K. Next, H. Okay, the determine and what is the spring stiffness? And the determine the speed when the sleeve is lifted by 50 mm. Okay, sleeve lift. So total sleeve lift they have given H. H they have given sleeve lift. See, H is the governor height for the Porter Governor. Here, H is nothing but a sleeve lift. For minimum position, H is H1. For maximum, H is H2. Okay, and we are taking H is equal to H1 by 2 for a derivation. But for a problem, they have given you H is equal to 50 mm. No issues. Now they are saying the initial compression of the spring. Now already guys, you have solved a problem. How to find out the initial compression of the spring? How do you find out initial compression of the spring? Initial compression चा formula काय होता कोणी सांगा आपण काय वापरलेलं H1 divided by K बरोबर ना spring force exerted at a minimum condition divided by K हा आपला फोर्स फॉर्म्युला होता तो आपण ऑलरेडी सॉल्व्ह केला फक्त आता आपल्याला काय बघायचं गव्हर्नर एफर्ट आणि पॉवर या दोन गोष्टी फार महत्त्वाच्या आहेत आता मी ते डायग्राम वगैरे काढत बसलो नाहीये सगळ्यांना माहिती आहे ओके तो फाइंड N2 del ओके इनिशियल कॉम्प्रेशन एफर्ट पॉवर ओके चलो तर तुमच्या समोर आय सेड ठीक आहे डायग्राम मध्ये काढणार नाहीये बट ऑलरेडी आय हॅव गिवन सॉरी आय डिडंट ओके सो नाउ दिस इज अ मिनिमम पोझिशन डायग्राम everybody knows how to draw the minimum position diagram this is a minimum see at this point you have a mg fc1 x y 0 see now in this problem they haven't said consider the obligatory effect so as I earlier said that if they are saying that don't consider the obligatory effect so means they have if they are not mentioning anything straight away neglect obligatory effect means what neglect the effect of mg then x is equal to x1 is equal to x2 y is equal to y1 is equal to y2 is it clear okay chalo so this is a minimum now anybody tell me anybody have a doubt how to draw this diagram the diagram does not change see this point where mg plus s1 by 2 is acting see we are doing a analysis for the half side na this is a governor axis this is a governor axis for this point let us say this point is r1 so at r1 you will have mg plus s1 by 2 and r2 you will have you can see here for r2 you will have mg plus s2 by 6 there is no any change x y fc2 mg and this is r1 and r2 see r2 is greater than r1 now obviously because as the speed increases centrifugal force increases radius of rotation increases so r1 and r2 are higher see what is r1 remember this point the center point of the fly mass and the governor axis is nothing but a r center mass of the fly mass and the governor axis is nothing but a r Remember this. Yes, message me. Do you have any doubt in minimum and maximum position diagram of the Hartnell Governor? No, na? Anybody? Shall I move forward? Okay, chalo, let's calculate. So FC1, now calculations are very easy. FC1, M1, sorry, M is constant. Huh? M R1 omega square. Okay. Yeah, now anybody take a moment. Chalo, we'll first take a moment for this. Anybody take a moment and tell me. Anybody movement for a minimum position diagram, taking movement about the point O. Anybody movement? Yes. Anybody be fast. I am giving you a chance. Anybody who can speak out how to take a movement? A movement.
mg
Take
plus h1 by 2
yeah,
multiplied
mg plus s1 by 2 multiplied by what?
by
Y. Today. Next. Next. What is?
y
What
minus
is?
fc into
Minus epsilon into x. Okay. And what about mg? What about mg?
plus mg.
Why?
Neglected.
Yeah, mg is neglected because we are not considering an obligatory effect. Okay, if there was a mg, if they said in a problem, I have already solved a problem on this. So you should take minus mg into, and that distance is a1. That distance is a1. Okay, this distance. You can draw like this, and this distance is a1. The distance between this point and this point we are taking it as a a1, right? And how to calculate a1? I have already solved the problem. Okay. So similarly, take a moment. Mg plus s1 is fc. So after taking moment, now you know m is equal to 4 s1. So from this you are getting, see, I have not changed the procedure. So you are getting s1. First of all, take a moment for minimum position. Find s1. S1 is nothing but a spring force exerted at minimum speed. Okay. So then find h. What is h? Now this formula is very very important. What to remember? Yesterday we have solved. We have done a practical on a virtual lab. So on a virtual lab also we have used this formula that h is equal to r2 minus r into y upon x, right? So same formula I have used over here. R2 minus r1 upon y upon x. Okay. So you from this you will get r2. Why you need a r2? Because you want to take a moment. Okay. And calculate the fc. Okay. So from this you will get r2. We know already r1. What is r1? That is given. Okay. So now, okay. Then now we know that h2 minus h1 is equal to h into h. Okay. H2 minus. Now basically see, basically guys, you have a two formulas. You have a two methods. What two methods? Now either you take a moment, take a moment, take a moment about O for a maximum position diagram. So I will go back backward. Okay, this is a maximum position diagram. For maximum position diagram, take a moment. What is the moment for the maximum position diagram? Tell me. See, it will be like this: mg plus h2 divided by 2 multiplied by y, and this will become plus now. fc2 into x, that is equal to 0. So from this you will get h2 and find out h2. Our regular procedure. There is one more. There is one more change or one more method you can solve. See, what is that method? Now, basically, guys, you know that initially in the original problem, stiffness of the spring was not given. Stiffness of the spring was not given. So I have to find S1 taking moment for a minimum position. I have to find S2 taking moment for a maximum position, and then I was finding a K. But in this K problem, the K is given. So find out S1 and no need to take a moment for a S2. No need to take a moment for the S2 because already they have given you the stiffness now. So what is the formula? Now you know the formula. This is the formula, na? Actually, this is a K, right? We know that K is equal to S2 minus S1 upon H, right? You know K, you know H, you know S. You can directly find out S2. Okay, but if the K was unknown, then take a moment and find S2, and then you will get K is equal to S2 minus S1. So these guys, you have to remember this. Okay, so this is okay. So from this, I am getting H2. Okay, and then from this, I am getting H2, and then you can find out. Take a moment, and then you can find out the FC2. Okay, because FC2 is equal to M R2 omega square. Okay, right? And here So omega square, I think n2 is unknown, na? N2 is unknown. Let me go to backward. I think n2 is unknown over here. So what I have given you? Yeah, they haven't given you the n2, guys. They haven't given you the n2, so you cannot find like this. You cannot find fc2 is equal to m r omega square, right? M r2 omega 2 square. You have calculated r2, but you don't know omega 2 because they haven't given you the n2. I think it is clear now. Okay, so that is why I have to go this. So first of all, find S2 from this formula. This is nothing but the K. This is nothing but the K. Okay, so then take a moment. So sorry, you have to take a moment because I thought N2 was given, but N2 is not given. So you have to take a moment. So from moment, what you are getting? You are getting FC2 is equal to, you are getting FC2, right? From moment you are getting FC2. Now you know the formula. FC2 is equal to MR2 omega 2 square. And from that, you can find out omega 2. And from omega 2, you will find out N2. Okay. So I hope it is clear to you. Okay. So in this way, so they have said you to find out the N2. So in this way, you have to calculate the N2. Now tell me, is there any doubt in this? Yes. Have you understand? Any doubt? Shall I move to the last part? Governor power and governor effort. It is very, very simple. Is it clear how I did? N2 was not given, so I have to K is given in this case. Okay. Okay, so I hope it is clear. Now initial compression on the swing, what is the formula? Initial compression on the swing is given by the del. Del is equal to S1 upon S. Basically, it is S1 upon K. It is not S, it is S1 upon K. So what is the answer? What is the answer? Okay. See, the answer is 16.51 mm. K is given. K mm. See, K I have taken in Newton per mm. Na? K is 20 Newton per mm. And this H1 is in Newton. So Newton will get cancelled and you will get answer into mm. So del is equal to m. Okay. And now governor effort. Now guys, believe me, to calculate the governor effort, it is very, very easy to calculate the governor effort. You don't have to remember that derivated formula for the Hartnell governor. See, it is very easy. Governor effort is given by P is equal to S2 minus S1 upon 2. The formula is S2 minus S1 upon 2. This is called the governor. The governor effort. Governor effort means what? The effort which is acting, or the force or the mean force which is acting on the sleeve when the equilibrium speed changes. See, you know, na, at the equilibrium speed, the mean force is 0. As the speed changes, the governor effort becomes maximum and again it becomes 0. So it's like this, 0 to maximum to 0 effort. Okay. So similarly, here what is the governor effort? In that case, there is a dead load. In that case, there is a dead load. In this case, there is a spring force. Okay. So that is why if you equate the spring force S2 minus S1 upon 2, you will get a mean force. And that mean force, so this governor effort is nothing but a mean force. Na? Governor effort is nothing but a mean force acting on the sleeve. म्हणजे स्लीवला रेजिस्ट करतोय तो राईज होण्यापासून, त्याला आपण मेन फोर्स किंवा एफर्ट म्हणतो. मग या केसमध्ये फोर्स कुठला आहे तर स्प्रिंग फोर्स आहे. सो यू हॅव टू फाइंड आउट द मीन स्प्रिंग फोर्स. अँड हाउ विल यू फाइंड आउट द मीन स्प्रिंग फोर्स? S2 minus S1 upon 2, and that is given by 500 Newton. And governor power is very, very simple. It is nothing but the governor effort multiplied by sleeve lift. Okay, and that is equal to P into H. Okay, so 500 and 0. And so in this way you can calculate.